morning, students. We were doing examples of exercise 6.2, right? Which was based on the concept applications of derivatives. We were doing increasing and decreasing functions, right, students? Yes? I had asked you all to try those examples. Did you all try? Did you all try to solve the students? No, right? You didn't try. Okay, let us solve those examples now. Before solving those examples, we will have quick revision. The function is said to be decreasing if f dash of x is greater or equal to 0. The function is said to be strictly increasing if f dash of x is strictly greater than 0. The function is said to be decreasing if f dash of x is less than or equal to 0. And it is said to be strictly decreasing if f dash of x is strictly less than 0. So these were the four important things which we learned to identify whether the function is increasing or decreasing by using the concept of derivatives. Right? So let us solve them one by one. I hope we had done with both examples. Right? So let us see the fifth one now. The fifth question is, find the intervals in which the function f given by f of x is equals to f of x is equals to 2x minus 3x square minus 36 3 or x is equals to minus 2. And these x values which we got 3 and minus 2 are nothing but the critical points. What are critical points? I already told you. Those points for which f dash of x is equals to 0. See, these are those points for which f dash of x is equals to 0. See, if you take 3 and put in f dash of x, if you take 3, this is f dash of x, right? This is nothing but f dash of x. And if you put 3 here, 3 minus 3 will be 0, and 0 into anything to be again 0. Take minus 2. If you put in f dash of x, minus 2 plus 2 will be 0, so again this term will go to 0. So these points, what are critical points? One more definition is those points for which f dash of x is equals to 0. Or you can even define it like this. Critical points are those points which divide the number line into disjoint intervals. See, once we get the critical points, we can find the disjoint intervals. What are disjoint intervals? This is my number line. What points did I get? One is minus 2 and other is 3. So what are the three intervals which we get? Three intervals which we got is, first one here it is minus infinity, here it is infinity. So what these two critical points are dividing the number line into three parts, right? This is one part, this is one part, this is the other. So what they are doing, they are dividing the number line into disjoint intervals. My first interval is minus infinity to minus 2. Here we are not including 2 minus 2 here. Here this will be not closed interval. Because if you include minus 2, f dash of x will be equal to 0. Right? So you will not include minus 2 here. So it will be open interval. So this is my first interval. Second interval, minus 2 comma 3. Third one, 3 comma infinity. So whenever we ask the interval, my first step is find f dash of x. Once you find f dash of x, equate that f dash of x to 0. So you solve the equation by some any method you will be using that. You will get critical points. What are critical points? Those points for which f dash of x is equals to 0. And those points which divide the number line into disjoint intervals. So by getting the critical points, we will get disjoint intervals. Now here we need to check in which interval. First one they have asked this increasing state. They have asked us this increasing. Instead it is strictly increasing. Instead it is strictly increasing. So we have to find in which interval the function is strictly increasing. We will consider it as strictly increasing. So we have to find in which interval the function is strictly increasing. Please consider in which interval f dash of x is greater than 0, strictly greater than 0. Right? So let us find in which interval f dash of x is strictly greater than 0. Let us say one by one. Observe your students. first option was strictly increasing, right? I told the next increase. So for which intervals the function is strictly increasing? For these two, this and this. So the function is strictly increasing. That is, f dash of x is greater than strictly greater than 0 for x belonging to these two intervals. That is minus infinity to union 3 to or minus infinity to 2 union minus infinity to minus 2 union into infinity. In these two intervals, the f dash of x is positive, right? Hence, in these two intervals, the function will be strictly increasing function. So, how you write it? Function is strictly increasing, that is, f dash of x is strictly greater than 0 for x belonging to minus infinity to minus 2 union 3 to infinity. So, in this interval, function is strictly increasing. Similarly, for strictly decreasing, function is strictly decreasing, that is, f dash of x is strictly less than 0 for every x belonging to which interval? In interval minus 2 comma, this is b1 answer. So the function is strictly increasing in this interval minus infinity to minus 2 union 3 to infinity, and it is strictly decreasing in this interval, that is minus 2 to 3. I hope everyone understood. Did you all understand this example? See, these steps only you are doing again and again in all the examples till 19. So you have to be very, very clear with this example steps. If they will ask you whether the function is increasing or decreasing, and if the interval is already given to you all, then not a worry. You can easily do it. But if they will ask you interval, in which interval it is increasing or decreasing, then you have to follow these steps which I told you. Okay? Okay, very good. So, continue to move further to the next example. So, the next question is, sixth one. We have to again find the intervals in which the following functions are strictly increasing or strictly decreasing. Okay. Sixth question, we have 5 sub questions in that, and again we need to find what intervals. So first A1, the function is given as, I am consider it as f of x. Okay. So what is f of x given? It is equal to x square plus 2x minus 1. X square minus 2x plus 2x minus 1. So here again we have to find intervals. I told you the steps right now, right? Now tell me, what is the first step? What is the first step here? Yes, first we have to find f dash of x, right? What is the f of x? Differentiating for the first time, that is 2x plus 2. So once you find f dash of x, my second step is equate it to 0. Equate f dash of x to 0. What does this imply? 2x plus 2 is equal to 0. So if you solve this, you will get the value of x. What is the value of x? It will be minus 2. So on equating f dash of x is equal to 0, we got what? What did we get? We got the critical point, right? So what is critical point? Already we know. The point which divides the number line into disjoint intervals is nothing but critical point. I hope you all know the meaning of disjoint. Disjoint intervals mean, suppose I have interval 1, interval 2. I say these two intervals are disjoint when they don't have anything in common. When they don't have anything in common. That is nothing but disjoint intervals, right? So what are critical points students? Critical points, definition is clear here. Those points for which f dash of x is equal to 0. And also how you can define it? Those points which divide the number line into disjoint intervals. Okay, please reply to this. So we want this critical point, right? What is critical point here? Minus 4. So let us see here on the number line. How it is dividing the number line into disjoint intervals. Okay, this is my number line. Suppose I have the critical point what? Minus 1. minus 1. So this is minus infinity and this is plus infinity. Right, students? Now, which are the two? We have only one critical point, right? So it is dividing the number line into two parts. That is two disjoint intervals. One interval is minus infinity to minus 1. Again, you are not going to include minus 1. If you include minus 1, the dash of x value turns out to be 0 because it is a critical point. Right? Next interval is what? Minus infinity to minus 1 to infinity. You can observe these two intervals are disjoint because we don't have anything in common. In both the intervals, minus 1 is not included. Right? So these two are my disjoint intervals. Now what we have to find? We have to find in which interval the function is strictly increasing or strictly decreasing. Let us find them one by one. First, in interval minus infinity to minus 1. Minus infinity to minus 1, what we have to do? Let us take some point. Suppose I take x is equals to minus 2. So if I take x is equals to minus 2, what will be my f dash of x, students? What was f dash of x here? It was something like f dash of x was 2 into x plus 1, right? 2x plus 2. It is nothing but 2 into x plus 1, right? F dash of x was 2 into x plus 1. So if I take x is equals to minus 2, what it will be? 2 into minus 2 plus 1 is minus 1. So answer you are seeing that we are getting a negative. So for this interval minus infinity to minus 1, f dash of x is less than 2. So in this interval, f dash of x is negative. Coming to the next interval, that is minus 1 to infinity. In this minus 1 to infinity, let us suppose I take some easy points, okay? So I'll take 0. For 0, what will be my f dash of x? F dash of x will be 2 into 0 plus 1 is 1. So answer is positive. So in this interval minus 1 to infinity, f dash of x is greater than 0. It is greater than 0. So it is positive. So let us again make the table. Let us make the table. We have two intervals, minus infinity to minus 1 and minus 1 to infinity. And in this interval, it was negative, so f dash of x is 1 less than 0. In this interval, it was positive, so f dash of x was greater than 0. Right? So if it is less than 0, it is strictly decreasing, and if it is greater than 0, it is strictly increasing. Right? So the function is strictly increasing function, that is f dash of x is greater than 0 for every x belonging to which interval? Minus 1 to infinity. So in this interval, the function is strictly increasing function and the function is strictly decreasing for every x belonging to which interval? So it's minus infinity to minus 1. Function is strictly decreasing, that is f dash of x is strictly less than 0 for every x belonging to minus infinity to minus 1. So in this interval, the function is strictly decreasing and in this interval, the function is strictly increasing. So we have found both the intervals for which the function is strictly increasing as well as the function is strictly decreasing. Did you all understood this? Yes, did everyone understand? Oh, very good. Only one girl is answering. What about others? I hope everyone is getting these answers, okay? These are very important. And I'm doing each and every sum so that it must be clear to you all. Okay? Oh. Now in this sixth one, first one we have done, A part we have done. B and D are similar. B and D, again we have quadratic equations there. We have to do in a similar manner as we have done in A. Okay? So we will do the remaining, like I will do C1. Take the C1. What is given? F of x is equals to minus 2 minus 9x square minus 4x plus What is the first step? First, we have to find the first order derivative, that is f dash of x. So what is f dash of x here, students? Minus 6x square minus 18x minus 12. This is f dash of x, right? Differentiating the function for the first time is nothing but first order derivative, and that is nothing but f dash of x. So once we find what is f dash of x, let us simplify this. I'll take minus 6 as common. If I take minus 6 as common, what is remaining? X square plus 3x plus 2. X square plus 3x plus 2, which is equal to minus 6. If you solve this equation, what are the two linear polynomials which you get? The two linear polynomials are x plus 2 and x plus 2. If you solve this quadratic equation, the two linear polynomials are x plus 2 and x plus 1. So what I will get? F dash of x is equal to minus 6 into x plus 2 into x plus 1. We got f dash of x there. Now once we find what is f dash of x, what we have to do next one? We need to find critical points, right? So that we need to find disjoint intervals. See, one are related to each other. As we want disjoint intervals, we need to find critical points. And as we find critical points, we will equate f dash of x is equals to 0. Right? So once we have found what is f dash of x, we will equate f dash of x to be equal to 0. So if you equate f dash of x is equal to 0, what you will get? Minus x into x plus 2 into x plus 1. We have equated f dash of x is equals to 0. So this minus 6 will be moved from it and will vanish off. So what are the critical points here? That x is equals to minus 2 or x is equals to minus. So minus 2 and minus 1 are my critical points. Once again I am defining critical points, so that it must be very clear to you all. Critical points are those points for which f dash of x is equals to 0. That means those points which divide the number line into disjoint intervals. Right? So here we have got two critical points. So these two critical points will be dividing number line into how many parts? Can you tell me? We have got two critical points. So these two critical points will divide the number line into how many parts? Two critical points will divide the interval into how many parts? Yes? Into how many parts it will divide? Very good. 3. So here I have minus 2, minus 2. So these two are my critical points, right? Here you will be having infinity. Here I have minus infinity. It goes to minus infinity, it goes to plus infinity. So which are those three intervals? First interval is minus infinity to minus 2. Second interval is minus 2 to minus 1. And third interval is minus 1 to 2. So we have got three disjoint intervals. Why they are disjoint? Because they don't have anything in common. Why they don't have anything in common? In these both intervals, minus 2 is not included. So there is nothing in common in these two intervals as well as in these two intervals. So all these three intervals will be disjoint. Right? Now let us find whether in which intervals my f dash of x will be positive or negative. Right, students? Let us take one by one. I will write directly the answer. We have done two problems. You must be familiar with it. So we have got three intervals, right? We have got three intervals. Now, let us take the first interval minus infinity to minus 2. So let me take any one point. Suppose I take x is equal to minus 3 in this first interval. In this first interval, if I take x is equal to minus 3, my f dash of x will be positive. Minus 6 into minus 3 plus 2 is minus 1. Minus 3 plus 1 is minus 2. Minus into minus plus, plus into minus minus. So answer is in negative terms. So for this interval, for all the points in this interval, my f dash of x will be what? Negative. It is negative. So let me write it here. It is negative. Coming to the next interval, minus 2 comma minus 1. Suppose I take some point in this interval. Say I take x equals to minus 1.5. Say I take minus 1.5 because minus 1.5 is this interval, right? Yes, of course. So if I take x equals to minus 1.5, my f dash of x will be minus 16 minus 1.5 plus 2. It will be 0.5 minus 1.5 plus 1. That will be minus 0.2. Right? So minus 2 plus is minus, minus 6 minus is plus. So answer is getting positive, right? So for all those values in this interval, minus 2 minus 1, f dash of x is greater than negative positive. Here I got negative, here we got positive. Next, coming to last interval, in the interval minus 1 to infinity. Suppose we will take very simple value that is 0. If I take 0, what will be f dash of x? F dash of x will be minus 6, 0 plus 2 is 2, so answer is negative. So for this interval, f dash of x is negative. That is, f dash of x is less than 2. So we got the intervals, right? We got the intervals. In this interval, f dash of x is strictly less than 0. Means what? The function is strictly decreasing. In this interval, f dash of x is strictly greater than 0. Means what? The function is strictly increasing. In this interval, f dash of x is strictly less than 0. Means what? It is strictly decreasing. So let us write the statements now. The function is strictly increasing function. That is, f dash of x is strictly greater than 0 for every x belonging to where it is strictly increasing. In this interval, right? Minus 2 to minus 1. Open interval minus 2 to minus 1. And where it is strictly decreasing, the function is strictly decreasing. That is, f dash of x is strictly less than 0. Where it is strictly decreasing? In these both intervals, it is strictly decreasing, right? So the function is strictly decreasing for every x belonging to minus infinity to minus 2, union minus 1 to infinity. Minus infinity to minus 2, union minus 1 to infinity. So in this interval, it is strictly increasing, and in these intervals, it is strictly decreasing. Did everyone understand? Did you all understand, students? I hope the problems are interesting, right? Yes, did you all understand? These are very easy, students. These examples, only two types of questions you will get in simplicial and differential functions. One type I told you, they will ask you whether the function is increasing or decreasing or no, or neither of them, by giving you the interval. And second type, this is very important. They will ask you to find interval. And if you remember the steps, any type of question you can solve. Okay? Now similarly, B and D are similar to first question A. As we have done C, I hope now you can do E1 also. It is similar, E1. Will you all try E, B and D? Yes, please. Will you all try B, D and E? Then you can make the conclusion statement. Right, students? So these steps and solve B, D and E. Okay? Fine. Any doubts, students? Do you have any doubts from today's class? And one more thing, students. You will be having exam on Saturday based on continuity and differentiability. I know I have not sent the notes yet, but I will ask you simple questions. Only it will be dependent on 20 marks. Okay? First exercise, I will send to you all the notes. I will try to send the notes within Friday. But you have test for 20 marks on the topic continuity and differentiability on Saturday. Okay? So be prepared. Thank you all, students. Have a great day.